Welcome, Nidhi. This is fantastic. Thanks for joining us. I'm very excited to learn more about your work at Amii and your research and about you. So maybe you could just start by telling us what your role is at Amii and maybe what got you interested in AI.
Well, thank you. Thank you for having me. I'm an Amii Fellow and a Canada's CIFAR AI Chair, and also an Associate Professor at the University of Alberta. My work is primarily in robustness and trustworthy machine learning, so privacy and fairness. I've only been at academia for about 4 years now. So before that, it was all industry research. And maybe about 10 years ago or so, we started having more data available to us. When I was working at Orange, France Telecom, a lot of networking data becoming available to us. So there was opportunity to do more sort of dynamic modeling and have, your model adapt to the data and so on. And then when I worked at Nokia Bell Labs, we started looking more at machine learning type of problems where what can we learn from the data and then implement something, for whatever purpose the company was interested in. That's how I became interested in machine learning. And then when I was at Technicolor, we had a specific problem about making movie recommendations, but in a distributed manner where, devices of users would hold the data. And then, you had to, in a privacy-preserving way, make movie recommendations. And that's how I became interested in privacy.
Oh, interesting. You had a specific application that got you running down this path. Differential privacy is obviously something that, theoretically guarantees privacy, but like in the application, it becomes a little bit more difficult, right? You maybe lose some accuracy in the model, you lose some utility. So I'm wondering, what are your thoughts on that? I mean, is this like an implementation thing where we just need to get better at implementing it, or?
Differential privacy is, sort of like current gold standard in the sense that most researchers have agreed that this is a, good mathematical definition we can all agree with because we're able to make mathematical or probabilistic guarantees. Of course, machine learning and all of algorithms that have been designed with a certain objective in mind, right? And that is, in machine learning, it's to improve the accuracy of a prediction, for example. That has always been the standard objective. So now if you add this privacy notion to it, in differential privacy, for instance, the way that you achieve differential privacy is by adding some sort of calibrated noise. So when you're adding noise, that means that you're going to lose accuracy. So there is a trade-off. And a lot of people have thought about this as, okay, where along this spectrum of trade-off should we be? What is a good spot to be in where we have good enough accuracy and good enough privacy, or do we want to focus on accuracy and maybe have a little bit of privacy? A lot of researchers are now influenced more and more by social science or others that have been looking into sort of general ethics of AI. So now people are thinking, okay, should we just change what our objective should be? Why should our objective always be, one particular thing? Maybe if you think of privacy as an objective, then it won't be like something you're giving up to get privacy, right? It would be that you're trying to satisfy both. So maybe that's a good way to think about it is in terms of numbers. Yes, there is a trade-off. You can lose on accuracy if you're trying to implement privacy, but it is also an implementation question. It's also depends on the context and the application. It depends on, how a certain model is trained. For example, if you're accessing the data set very often in the training, then you need to add noise every time you access the data set. So, people are coming up with methods of adding noise that are more and more tight in the sense that we know how to characterize more tightly how much noise we need exactly. And so that helps us in reducing that loss in accuracy.
Interesting. AI is moving very quickly right now. It feels like the pace. Do you think that privacy is keeping up or it's where it needs to be? Or is this something that needs more of a push on?
I think it depends on what you're trying to protect, what kind of an attack you're trying to prevent. Differential privacy, the way it was conceived, was originally for a specific type of attack where you don't want to be able to infer what data point it was in the training data set. But there might be other kinds of attacks we might be interested in today. For example, with large language models, people have found that because of the capability of memorization, if you give it a certain prompt, it may complete it. And in doing so, it may reveal a private information that was in its training data set. So this is kind of the opposite problem where, oh, I didn't know this information existed for me to know if it was in the training set. Now this model is just telling me, this information. So maybe the way that differential privacy was originally conceived or way that it is implemented, in standard like classification type of models doesn't really apply anymore to these models. And we need to think about other ways of approaching this problem because the type of attack or the type of breaches are different.
I know you do a lot of work in fairness too, in addition to privacy. And I'm just kind of wondering, what are your go-to ways of ensuring a model is fair? Is it in the model training? Is it just evaluation? I mean, what are your thoughts on that?
There have been many different types of algorithms that have been proposed for mitigating unfairness in outcomes of machine learning models. The approach that we're taking in our lab is to change the objective function of the machine learning model itself so that you have fairness. Standard loss functions or objectives in machine learning will minimize the average loss. But instead, what we would like to try to do is have some kind of a more robust loss in the sense that instead of minimizing the average loss, maybe we want to minimize the worst case loss of a particular group or a worst case loss according to a particular proximity of the data points that you have. And if you have more robust objective functions like that, we've shown that you end up with models that are fair, even if you didn't have specific fairness constraints in your formulation.
Oh, I think that's great. I mean, I think you don't hear a lot of people talking like that about implementing fairness. It's usually just about the evaluation at the end. So I think that's really novel. So is there anything coming out in your research group that you can share with us?
Well, we're trying to develop a sort of a series of work that follows up on this idea of having a more robust objective function. So a couple of years ago, master's student Liam Pete Paré, he started this work on using what's called distributionally robust objective. And that was for, classification type of models that we looked at. But this general idea of distributionally robust optimization, is not new. It's just been used for different goals. So we're trying to see if we can use this for other applications. And a student, Deep Gandhi, who's just graduating now with his master's, we applied this objective to fine-tuning of large language models to see if it helps with debiasing of the output from these language models.
Interesting.
So we're trying to see if this notion of, robustness with the goal of fairness can be applied in a lot of different applications.
Oh, very cool. A lot of people from a lot of different angles talk about privacy in AI. What do you think the public should know about privacy in AI models?
If it becomes harder and harder to understand actually what the machine learning model is doing, then, I don't know what kind of a mental model I should have as someone not in the field, say, of what privacy could be. Like, I have things I've written on Facebook. Maybe I've shopped at a certain online store, things like that. Is this all part of the data that these large models are scraping? How much actual information is in that data about me? Like,
so those are the things for the public to worry about.
Yeah, but actually, I think it'll be hard for them to even know the scale of it. There's this entire billion-dollar industry for the market, for data markets, and there's data brokers and people at the microsecond that this data is created. These things are traded and bought and sold. There is, a lot of power in combining all the data to get information. And I'm not sure that the public is aware of a lot of this. But also on the other hand, we don't want to sort of go too far on one side and say every single data about you has a potential for some kind of a public, privacy breach or inference about something you don't want to be known, because there are going to be some things that we may have to give up in order to take advantage of the benefits that we get from AI. So, if this is going to help with predicting disease for a minority population, then maybe I'm okay with that, right? But if it's going to mean you're going to send me more ads about red shoes when I've already bought the red shoe, then maybe I don't care and I don't want it.
Yeah, it's just feels like maybe there needs to be more reasonable education rather than just kind of fear-mongering news stories and stuff.
Yeah. Yeah, because I think if you already start talking about privacy and fairness and bias without, the audience that you're speaking to having any knowledge about AI or data or the power of these things, then you're sort of coming at it the wrong way. You're talking about the boogeyman without talking about, oh, there's all this other stuff. There's this gate that's going to stop the boogeyman. It's becoming more and more important, even critical, for us to start having better ways of educating and sharing the knowledge about AI, machine learning data with the public, especially with kids in school right now.
I've recently heard that you have started working on machine unlearning.
Yeah, it's an exciting new problem area. I think it started with directives and legislations in the EU about the right to be forgotten. As models get more and more complex, it's harder to take out the data or take out the influence of the data. And it's not even clear if it's possible for some types of models. Like these sort of generative AI models have already learned from large-scale data sets. And so now if you need to remove someone's data, this is a very hard problem. People are talking about like redaction, where maybe you're not completely forgetting data, but you're somehow...
It's kind of a kludge at the end, kind of you're redacting something after it's being spit out.
It should appear that way, yes.
Should appear that way.
But probably something's happening in the way you're modifying the model. I consider this to be still early stages.
Right.
Of course, the way things are progressing, early stages don't last too long, so we need to move quickly. But
I mean, are there any promising ways of doing this? This seems like a really hard challenge.
So we talked about differential privacy earlier. So some people are trying to, make machine learning sort of like differential privacy. The definition of differential privacy is that the presence of a particular data point in the training data set should not be obvious in the output of a machine learning model. That's kind of, the basic core of differential privacy. So that's kind of like this notion of machine learning, where you should not be able to know whether this particular data point was used. There's some intricate differences between the two notions of machine learning and differential privacy, because you want to be able to create this without necessarily impacting the accuracy too much. You still want the model to be able to predict with similar accuracy, but somehow not have the influence of this data set. So differential privacy is like one way to get started on it, but there might be, other ways or other definitions that we will have to come up with.
It's a really fun challenge.
For me, this is definitely one of the challenging problems I'm looking forward to.
Thank you so much for joining me. It has been awesome to learn about your research and lots of things to think about here, and really interested to see what comes of what you're working on.
It was great to speak about all of these exciting things happening.
Yeah, thank you.